In this video, we're gonna find extrema on a graph. Extrema will give you an interval and the function. So let's go ahead and look at the objective for this video. Number one is define extrema. Number two, define critical points. Number three, can you look at a graph and state the extrema? Now we're gonna have two types of extrema. We're gonna have absolute and local. Now in some textbooks, some people use local while others use relative. I know that the AP exam will use the word relative extrema, while some books are going to use local extrema. Given an algebraic function, can you find me the critical points? Another objective for this video is given an algebraic function, find me the extrema. And then finally, if I give you an interval and a function, can you find me the extrema on that piece of graph? All right. So let's go ahead and define extrema. All right, extrema, you need to understand are maximum points and minimum points. Okay, so it's going to be both minimum and maximums. Now, so what is an absolute maximum? Let f be a function with a domain D. Then f has an absolute maximum value on D at a point C if f of x is less than or equal to f of c for all x in D. Now, some students are going to get a bit confused on this. So what I need for you to understand is this guy, he's going to be my extrema. All right? So that's going to be my max. Now it's saying this. Please understand, x equals c is my x value, but f of c is my y value. So f of c is greater than all the other f's, all the other y's. Okay? So that means that this guy is the highest point. Now, it can be equal to the highest point, so that means that if this guy is the highest point and there's another one that has the same y value, this guy is still considered a maximum even though this guy is at the same location. So it just says that this graph is going to have two maximums. Now, it's considered to be a minimum if f of c is the lowest point, or it could be one of the lowest points for that function. Okay? Now, local or relative are going to be a bit different. Okay? A function f has a local relative maximum value at c within its domain. If f of x is, again, we're talking about maximum, so that means that the dot is going to be greater than or equal to any other dots for all x, an element of D lying in some open interval. In other words, if I give you a piece of graph, then it's going to be a local maximum. Okay? And then it's going to be a local minimum if f of c is greater than or equal to all the other dots, right? For all x, an element of D lying in some open interval containing c. So what, a lot of you are going to say, sir, I still don't get it. Let me explain. This picture has that dot right there, and that dot is the absolute max, meaning that's the highest dot. There's not going to be a dot ever, because this function is going to go down forever and it's going to go down forever. So that's an absolute max. So when I do a graph like this, now this here, this dot right here, people are saying that's a maximum. Oh, wait, stop right there. That's not a maximum value. It's not an absolute. Why is that not an absolute max? Because there's a dot here higher, there's a dot here higher. There's going to be more dots on the right side here that are going to be higher. So all these dots are higher than the dots. So that is not an absolute max. So, but however, if I had some piece, some interval, like let's pretend that I went from here to here, I have that little interval, then you can say that this guy is going to be a max. So they're going to call him a relative max. A relative max or a local max. And this dot down here, he's not an absolute min. He's going to be a relative min. Or, as the others say, a local minimum. Okay? I hope that clarifies the difference between an absolute max and a relative max, and a absolute min and a relative min. Now you're saying, well, can you show me an example of a absolute min? Yeah, I'll show you one right here. Let's pretend I go like this, all right? So this guy right here, that dot right there that I just highlighted here, let me see that guy, he's gonna be an absolute min. And this dot here, he's gonna be a relative min. Okay, so he's gonna be a low point and on some open interval, but over here, he's going to be the lowest ever, okay, in the whole graph. Now, we need to understand what a critical point. A critical point is where my slope, okay, my derivative is equal to 0 or undefined. So anywhere on my graph where I have 0 slope or undefined slope is called a critical point. Now, a lot of you are very quick to point out, how many critical points does this guy have? And the answer is going to be 2. It has a critical point there and a point there. So that guy is going to be a CP and a CPA. Did you notice something unique about that? Wait a minute, sir. That's a relative max, and that's a relative min. So extremas, you can almost say here that a lot of them are going to have a slope of 0. Okay. Now, let me show you where it's undefined. Let me show you a picture of a graph where it's undefined. So let's pretend I get like this, like this. Wait a minute. What do I see right here? I see a cusp. So that guy, he's going to be a critical point. That we say that my slope there, f prime of x, is undefined. It does not exist. Okay? So let's try another one. What about something like this? Let's pretend I went like this, then I go like this. Ooh. So right here, I just created a vertical piece right there. So that guy, my slope is undefined. So we're gonna say that guy, he's considered a CP also. So you see what I'm talking about? Critical points are going to be where you have extrema or where you have undefined points, undefined slopes, I'm sorry. So right there, that point exists and my slope is undefined. That point exists on my graph and it's undefined. So what can we say? We can say that all extrema, well, I don't want to say all extrema, I mean most of the extrema, because let's pretend I gave you a piece of graph. See that piece of graph right there? That graph right there, well, you can say he's a maximum and he's also a critical point. Yeah, it's undefined there at the end. So all extrema are critical points, but not all critical points are extrema. Okay? So, and what's an example of that? Something like this. Remember what I did right here? Oops, that's a horrible picture. Right here, my slope is undefined, so that's not a max or a min. Okay? So it's not an extrema. Here's another one. What about this guy right here? This guy right here, he's gonna have a slope of 0, so he's a CP, but he's also not considered a extrema. He's not a max or a min. He's a flat line. Okay, so this is gonna lead us to a theorem. If f has a local max or minimum value at C of its domain, and if f prime is defined at C, then f prime of C is equal to 0. Okay. All right. So all you're gonna do is you're gonna look at a graph and tell me my extrema. All right, state the extrema of this. Well, I can say, sir, it has 1, 2. This guy is going to be a relative min. This guy is going to be a relative min. But this guy, he's going to be unique. If this continues to go up forever and this continues to go up forever, then I can actually say that this guy, he's an absolute min. And then the other ones, this guy here, this point right there, he's going to be a relative max, and this point is going to be a relative max. So I have relative max, 2 relative maxes and 2 relative min and 1 absolute min. Okay, so now let's find the critical points. How do you find critical points? Well, that's easy, sir. All it says is critical points is where f prime of x is equal to 0 or f prime of x is undefined. Okay, so I'm going to take the derivative. Y prime is going to equal to 12x plus 3x squared. I set it equal to 0. I factor out a 3x and I'm going to be left with a 4 plus x is equal to 0. And according to the principal product of 0, what's going to give me 0 there? Well, x equals to 0. And what's going to give me 0 there? Well, x is equal to -4. So therefore, I have CP's at x equals -4 and x equals 0. And I'm done. Okay? Let's try it on. Ooh, this one here is kind of unique, right? So on this one, I'm going to have a function here, and I actually gave you the graph. So let's take the derivative of that. So I got to take the derivative of the top, which is 2x times the bottom, x plus 2, minus the derivative of the bottom times the top, all over the bottom squared, x plus 2, okay, squared. And this is equal to y prime. So now I'm going to simplify the top. So I'm going to distribute here, and I'm going to distribute here. So I'm going to end up with 2x squared plus 4x minus x squared over x plus 2 squared. Now, the great part is I know that this function has an asymptote at x equals -2, so I'm not going to worry about the denominator. So if I simplify the top, I'm going to end up with x squared plus 4x, and I'm going to have x plus 2 squared. And I'm going to set that equal to 0. So I'm really only concerned with the numerator, because the bottom is just where it tells me where I have an asymptote. So x squared plus 4x is equal to 0. I factor out an x, and I'm going to be left with x plus 4 equal to 0. By using the principal product of 0, I have x equals 0 as a CP and x equals -4. So these here are my CPs. So if I notice, I'm going to have 0 there. 1, 2, 3, 4. If I come down, and there's going to be my 4. Okay. So I found the correct critical points. Now, here's a problem where students have difficulty. I give them a piece of graph, and I want them to find me the maximum and minimum values. And I'm going to clarify something right here. If I give you the word value, this means the y coordinate. Okay? From now on, if you ever see find me maximum value, find me minimum value, then you find me the y coordinate. If I says find me the maximum, find me the minimum, well, you could give me an x coordinate or you can give me the y coordinate. But the word value means the y coordinate. So when I give you an interval, a piece of graph, and I give you a function, number one is find the y at the endpoint. So I'm going to make a very simple table here, and I'm going to put x and y, and I'm going to include my -2 and my 3. They come from my interval. So I'm going to try to find my y coordinate. So I'm going to plug it in here. If I plug it in, I'm going to end up with if I plug it in, I'm going to square 4. It's going to be the cube root of 4. Okay. If I take my 3 and plug it in, I'm going to end up with a cube root of 9. Okay. And now what I want to do is I want to be able to find my y value at my CP. So I got to find my critical point. So I'm going to take the derivative of that. So I'm going to come over here somewhere, and I'm going to say f prime of x is going to equal to 2/3 x to the -1/3. So that tells me to shove it to the bottom. So 2/3x to the 1/3, which I'm going to write it as 2/3 cube root of x. And when I set that equal to 0, the only thing that I'm really going to get is I'm going to get undefined when x is 0. So 0 is going to be a critical point there. So when I plug it into my original function, I'm going to get 0, 0. So now that I have this, I'm going to try to find my y value. So I'm having the cube root of 4 and the cube root of 9. So we can honestly say that the cube root of 4 is going to be smaller than the cube root of 9, but that's going to be some positive value. So I'm going to try to find my value here. What's the lowest point here? This is going to be some positive y, and this is going to be some positive. So this right here is going to be my minimum. Okay, so my minimum is going to be located at 0, 0. So my minimum value, all right. So my minimum value is going to equal to 0. Now, what's my maximum value? My maximum value is going to be the highest of those points. So I'm going to find the maximum is going to be the higher of the two. So what did I say was larger, the cube root of 4 or the cube root of 9? And the cube root of 9 is larger, so we're going to say that the cube root of 9 is my maximum value. Now, for those of you that are visual learners, I graphed it in my CAS. So let me bring out my CAS here. And this is the picture of x to the 2/3. But I was given the picture only from -2 to 3. So here, right here, I'm going to end up the point for my value at -2 is that dot. And then for 3, it's going to be that dot. So which one was higher? That dot or this dot? And it looks like I'm going up. So this is my maximum value. Okay. Now, one of the things that they love to ask, it says, I'm going to give you a function, and it says, find me the maximum and minimum values of a function. So I'm going to be looking at this, and I know that this right here is a quadratic function. So what I'm going to do is I'm going to find the critical points first of all. F prime of x is going to equal to 2x minus 3, right? So I'm going to set that equal to 0. So 2x is going to equal to 3. I divide by 2. I divide by 2. So that means that x is equal to 3/2. Now remember, they're asking for values, right? So x, now, is this going to be a max or a minimum value? So I know that from college algebra that this is going to be a quadratic function that opens up. So I know that this guy, he's going to be an absolute min. But it's not going to have a minimum value. So this guy is out. So there is none. No, there is not going to be any. I'm sorry. I crossed out the wrong one. It opens up, so it's going to be a minimum value, right? So I'm going to do one more here. This is the one that's out. So how do I find the value? Well, I have to take the x coordinate now and plug it back to my function. So I'm going to try to find the f of 3/2. So that's going to give me 3/2 squared minus 3 times 3/2 plus 7. So that's going to give me 9/4 minus 9/2 plus 7. That's going to be 9/4 minus, and we can say that multiplied by 2 is going to be 18/4 plus 28/4. Okay, they all have the same denominator. So 28 minus 18 is 10. 10 plus 9 is 19/4. So this is going to be my absolute minimum value. All right, and that concludes the video.